Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We are going to start into Chapter 2 here today, and in Section 2.1, the first thing that we are going to look at is reviewing over some topics from complex numbers. I think most of what we go over will be reviewed, but there may be a couple of topics that you did not see last year in Algebra 2. So, first off, when we talk about complex numbers, well, technically I, by definition, I is the square root of -1. We'll certainly talk more about that, but it's also kind of our base for complex numbers. Now, because I is the square root of -1, if we would square both sides, I squared is -1. Now, in terms of I to the third, well, that's like saying I squared times I, which I squared is -1, so -1 times I is -I. And then for I to the fourth, there's two ways you could look at it. You could either say it's I squared times I squared, or even I squared to the second, because you'd multiply those. Well, I squared is -1, -1 squared is 1. So what that means is anything beyond there, like if you have I to the fifth, well, that's like I to the fourth times I, which is I to the sixth, I to the fourth times I squared. Well, again, I to the fourth is 1. 1 times I up here was I, 1 times I squared. Well, I squared is -1, so that's -1. And then I to the fourth times I to the third. Well, again, that's 1 times I to the third, which is -I. And then the final one, I to the eighth, I to the fourth times I to the fourth. You could have said it's I to the fourth squared. Either way works, but it's just 1 times 1, which is 1. So those are some kind of general definitions of complex numbers. Now, in terms of, or I guess I should say imaginary numbers, complex numbers where you have a plus bi, where it has a real component, which is a, and then the bi is the imaginary component. So, if you're just adding 5 plus 2i plus 6 minus 8i, whether or not you remember going back to last year, it's just like combining like terms. 5 plus 6 is 11, 2i plus -8i, -6i. For question 2 here, well, we are going to distribute the negative and then combine like terms, and certainly if you would not have needed to do that in a separate step, no problem there. All right, if you have a number outside of parentheses, we're just going to distribute it. 6 times -3, -18. 6 times 2i is 12i. All right, so those are all pretty straightforward. Example 4, again, we'll distribute. I times 5 is 5i. I times 2i, 2i squared. Now, here is where, I know like if these were just variables, you'd be done. Well, again, coming back up to these definitions up here, I squared is -1. Well, this ends up becoming 5i plus 2 times -1, so it's 5i minus 2. And again, if you do not need to, actually show this step, if you go from here to here, that's certainly fine. So, those are some general operations with complex numbers. And then one final one, if you have something like 4 minus I times 4 plus 3I here, all you're going to do is FOIL that out. So 4 times 4, 16, 12I minus 4I minus 3I squared. So certainly, again, as many steps as you need to do this, 12I minus 4I is 8I. Keeping in mind that is -1, so that becomes +3, and then 19 plus 8I. All right, conjugates. We've talked a little bit with conjugates with radicals. If you are going to divide, well, the problem with division, you do technically have a radical in your denominator here. So in order to get rid of that, we are going to use the complex conjugate of the denominator. And we multiply top and bottom by 1 plus I. So when we do that, the top is 5 plus 5I. Your denominator 1. Now, I'm only going to show this in this first example. When you FOIL, well, the reason we use the complex conjugate, that allows our middle terms to cancel. So now we have 5 plus 5I over 1 plus 1, which again, as you guys work through these problems with complex numbers, you can certainly determine how much work you actually need to show as you do these. All right, so there is a division problem. Probably the single biggest thing to caution about is when you use the conjugate. Notice the only thing you change is the second sign. Do not change the first. Sometimes we see that. If you do that, then you'll end up with imaginary terms in the denominator. So, as far as this one goes, we'll FOIL out the top. So 8, 4I, 12I, 6I squared. The denominator, 16. Again, I'm not going to actually show the minus, and plus 8i's canceling out, minus 4i squared. Now, from here, keeping in mind you have a -1 here and here, so that's going to give us 8 minus 6 is 2, plus 16i over 20. Now, kind of like when you do the quadratic formula, sometimes you get to this point and you aren't quite finished. Example 6, we couldn't reduce. 2 plus 16i over 20 will. All of these reduce by 2, so 1 plus 8i over 10. All right, one of the things that I know back when I used to teach Algebra 2, we did not always talk about this issue in one of the ways we are right now. So this is where I say one of the things we look at may actually be a little bit of a new concept here. And that is if you have the square root of any negative value, basically what we are going to do is we're going to treat that like it's the square root of -1 and the square root of a. The square root of -1 is I. Square root a. Now, the reason why this is important is if you have something like example 8a here, where you are asked to simplify, one of the things that certainly is a common thought is, oh, you know, we have 2 square roots, we can multiply the numbers underneath them. Well, yes and no. The first thing that we do have to do, though, is we do need to simplify out the I radical 3, I radical 8. And so then that becomes I squared radical 24. Here's the problem. If you multiply these first, you still end up with a positive 24, but you don't have the I squared, and it will change your overall answer. Now, we do still need to simplify our radical here. 24 will split into 4 and 6, so this is 2 square root of 6, and then remember, going back to first page, I squared is -1. So that's -1, or just now -2 square root of 6. So this is where you do have to be careful. If you multiply first, you don't have the I squared. And so instead of a negative answer, you would have ended up with the positive. So again, that's one of the things you do have to watch with these. Just a couple of other examples, certainly here. Now, you don't have to necessarily take the negative out as a separate step. If you have something like here, the square root of -32, if you see it is one that will simplify, you can kind of do that together. So this will be square root -16 square root 2 minus, and then the square root of -18 is the square root of -9 square root 2. Well, the square root of -16 is 4i radical 2 minus square root of -9 is 3i square root of 2, and then when you subtract, that is I radical 2. All right, for example C, when you FOIL -1 plus square root of -3, again, before we FOIL these, let's go ahead and actually, if you had wanted, you could have said this is -1 times square root -1 times square root 3. That's where the I came from. Now, we will FOIL this out. So -1 times -1 is 1, plus the -I radical 3 and -I radical 3. Didn't really need the plus the negative there. And then at the end, I radical 3 times I radical 3 is I squared. Radical 3 times radical 3 is 3. Now, as far as what we end up with, again, that's -1. So that's 1 minus 3, so -2. And then minus 2i radical 3. All right, one final question here. Going back to quadratic formula, I think it's possible even one of your Pearson questions may have even had you do this kind of in advance, so this may not even be entirely new. Here, if we're going to solve this, because not only is A not 1, but also with B being an odd value, I would not complete the square. So when we use quadratic formula, opposite of B is +5 plus or minus square root. B squared is 25 minus 4AC all over 2A is 4. And so from here, 5 plus or minus, let's see, so that is -56. And certainly, again, kind of up to you as to just how much work you need to show. If you don't even need this step here and you can get directly to that -31, that's fine. All right, well, again, because we have a negative under the radical, it is going to give us complex or imaginary answers. Even though we can't simplify -31, we are still going to use that -1 and 31. And so when you do that, 5 plus or minus I radical 31 over 4. So Again, some review of some topics with complex numbers, maybe one or two new concepts in there as well, but that is everything we're going to look at out of section 2.1.